Hi all. So here we're going to do a couple examples of normal probabilities that are not standard normal. Uh, these are ones that don't have a mean of 0 and a standard deviation of 1. So in this example, prices of a certain type of car follow a normal distribution with a mean of $40,000 and a standard deviation of $5,000. So here our units are are in thousands. And in the first part, part A, we want to find the probability that a randomly selected car costs more than 51,500. So I drew the normal distribution with the z's and the x's. So the mean is of 0 lines up with our mean of 40,000. And one standard deviation above is 45, and two standard deviations is 50 because the standard deviation is 5,000, and three standard deviations above, and then going the other way, one standard deviation below, two standard deviations below, and 25 below. Three standard deviations below. Okay, so let's draw what we want to look as costs more than 51,500. So 51,500 is probably around here. So let's just draw that in. That's 50. Just remember what we're looking at. So point. And let's shade to the right because we're looking at finding the probability that it costs more than. Okay, so to find the probability that that x is greater than 51,500, that is going to equal, we need to convert our x's to z's, so let's just write this. So that's going to be probability that z, so the formula for z is x minus mu over sigma. And if you didn't know that, review the lecture that I just had. Is greater than, because we're looking at more, 51,500. That's our x. So we're just getting everything from this formula. And our mu is given, that's 40,000, so minus 40,000. Divided by our standard deviation, which our standard deviation is 5,000. So 5,000. Okay, so that equals, so this whole thing equals 2.3. So we have the probability that z is greater than 2.3. So looking 2.3 up in the standard normal distribution table, we get 2.3. This is the positive side, 2.30. So 0.9893. And keeping in mind, these are the areas to the left, so we just have to do 1 minus 0.9893 to get the area to the right. So we get equals 1 minus point, what did I say, 9893, which equals 0.0107. Okay, and if we look back at the graph, we can kind of see by the shading this area, we know that the probability is going to be less than 0.5, and that's exactly, since this is so small, and that's exactly what we'll get. It's a very small percentage. Okay, so using the same mean and the standard deviation for this second example, we want to find what percent of cars cost between 32,000 and 47,000. So if we draw that, so 32 is probably around here, and then we get 47. So we shade in between because we want to know the area between this. So we're going to do the same thing as we did before. We find the probability, I just like to type this out, the probability that x is between 32 and 47, which equals that. So then we get that equals the probability that, and using the formula, we get what's our x is 32 on this side, so 32 minus 40, sorry, clean that up a little bit, so minus 40 over the standard deviation, which is 5,000, so we can just use 5, is less than z, so x, the formula for z, x minus mu, just like we just did, over sigma is less than, so our other one is 47, our x, minus 40. Hopefully you get the hang of this by now. Okay, so divided by 5. Which equals, if we calculate those, so this whole thing is going to equal negative 1.6 less than z, and less than, okay, this whole thing equals 1.4. So we look on the normal table again, and keeping in mind to find this probability, we need to find first, so this is going to equal the probability that z is less than 1.4. So if we were to draw, right, if this image helps a little bit, this is what we're going to do. Sorry, not a standard, but so 1.4 less than, so that's on this side, right, minus the probability on this side. So minus the probability that z is less than negative 1.6. So we look on the normal distribution table and find 1.40 is 0.9192, and then for the negative 1.6, negative 1.6, we get 0.0548. Putting that down, we have equal 0.992 minus 0.0548, which gets us a probability of equal 0.86 4 and 4. So stay tuned for more examples.